If you're given a chart of two functions, f of x and g of x, which are both continuous lines for all real numbers, and you want to determine when, let's say, f of x is greater than 3, the first thing you have to do is look in the f of x column and find 3. We'll note that that happens when x is negative 1. The next thing you have to do is you have to look and see where the numbers in the f of x chart are greater than 3. So 6 is greater than 3, 9, 12. These are all greater than 3, whereas 0 is not greater than 3. So we want all of the numbers that are below in the chart, negative 1. Well, in our chart, the numbers that are below negative 1 are actually numbers that are larger than negative 1, right? 0, 1, 2, 3. We want the numbers for x that are greater than negative 1. So we could say x must be greater than negative 1, because in the chart, all the values of f of x at numbers more than negative 1 are more than 3. We could also write this in interval notation, saying negative 1 to infinity, because we've said this is continuous line. It's going to be a continuous line for all real numbers. Every x value more than negative 1 should give us a f of x value more than 3. So we'll do a similar thing for g of x less than or equal to 7. We'll find where g of x equals 7 in that column. That'd be at x equals 1. And then we want numbers that are less than or equal to 7. So that's these numbers. The numbers that are less than 1 give us g of x values less than 7. So we want x to be less than positive 1, because this was a positive 1. But it could also be equal to 1, because this has an or equal to. So it's okay for x to be 1, because then we equal 7. And this says that g of x is less than or equal to 7. We could also write this in interval notation, knowing that if we think about numbers that are less than 1, that's 0, negative 1, negative 2, all the way down to negative infinity at its smallest, until we get to 1 with a bracket, because it's less than or equal to. To find when f of x is less than 8, we need to find the value of 8 in our f of x column and see which values of x give us numbers less than 8. Right? All of these are less than 8. So we want the x values that are less than 2, because those are the values that give us f of x to be less than 8. So x is less than 2. If we're talking about numbers less than 2 in interval notation, those are numbers like 1 and 0 and negative 1 and negative 2 and all the way to negative infinity. And we stop at 2 with a parenthesis, because it is a less than, not a less than or equal to sign. For g of x greater than or equal to 4, we'll look in the g of x column for 4, and then we'll look for where the numbers are more than 4. 5 and 6 are more than 4. So we are interested in the x values for g of x that are greater than 1, 2, and 3, and 4, and 5. So we will say x must be greater than or equal to 1. We can keep the equal to, because this inequality had an equal to on it also. And in interval notation, greater than or equal to 1 means you start at 1 with a bracket and go towards infinity. To determine when f of x is less than negative 5, we'll again just look in the f of x column for negative 5, and then look for numbers that are less than negative 5. So sometimes students have a little bit of difficulty figuring out when something is less than a negative number. We have to keep in mind that even if it looks larger, like negative 9, 13, 17, those are actually less than negative 5. You can think about it in terms of money. If you owe me $5, that's a lot better than owing me $9 or $13 or $17, right? You have less money if you have negative $17 than if you have negative $5. So the numbers that are less than negative 5 come from these x values that are greater than 0, because 1 and 2 and 3 are greater than 0. So we'll say x is greater than 0. And again, we can write that in interval notation, starting at 0 with a parenthesis and going to infinity, because we want the numbers greater than 0. And if it helps you to write out the interval notation, you can always make a number line, right? If you know x is greater than 0, that's an open circle going to the right, and that's what our interval notation should look like. If we want g of x to be greater than negative 8, we'll look in the g of x column for negative 8 and find the numbers that are greater than negative 8. So negative 3, 2, and 7 are all more than negative 8, right? Positive numbers are more than negative numbers. So we're interested in the numbers that are less than 1, because 0, negative 1, and negative 2 in our x column are less than 1. So we'll say x must be less than 1. And in interval notation, if you were going for 1, here's 1, less than 1 would be from negative infinity until we got to 1. And again, it's a parenthesis because it's just a greater than sign. All right, we'll do 2 more of these. So we've got f of x is greater than or equal to 1. So first you look in the f of x column for when f of x equals 1. Then you look for numbers greater than 1. That'd be 3, 5, and 7. So we want the x values at which we are greater than or equal to 1. That would be when x is greater than or equal to 0, or in interval notation, a bracket on the 0 towards infinity. If you want when g of x is less than or equal to 3, we'll look at g of x equaling 3. And then we want the values that are less than 3. That'd be 2 and 1. So we'll use these same values down here. We'll say that x must be greater than or equal to 1, which should give us a bracket with the 1 towards positive infinity.